first a little bit about the motivation behind this mission. And the big motivation for a lot of people, and for me too, I have to say, is to try to understand how Mars climate evolved, and whether or not Mars had life at any time in the past, and whether or not it could even harbor life today. Because the more we look at forms of life on Earth, if we look in more and more remote places, we drill cores down into the crust, we look at the deep sea, look at these vents, we find life in more and more extreme situations that we did not expect. And it turns out that there are some forms of life that if you went down into the surface of Mars, some forms of life on Earth could survive there. So it is possible to have microscopic forms of life on Mars today. And even if they're not there today, it's possible that we could discover fossils, because we've gotten a lot better at finding and recognizing microscopic fossils. And that's opened up a whole area of paleontology, these small forms of life, and pushed back the history of life, the recorded history of life, much farther into the past. So for life, Mars has today, or has met at one time, all of the requirements. Liquid water, access to biogenic elements, and by that I mean just the common elements, carbon, nitrogen, oxygen, hydrogen, sulfur, phosphorus, and so forth. All of these elements are abundant in all of the terrestrial planets, even in Mercury. But Venus, Earth, and Mars have all of these elements in abundance. And the source of energy to drive metabolism, so that source of energy would be?
The sun.
The sun. And either directly or indirectly, one way or another. By the way, this is ALH 84001. ALH stands for Allen Hills. It's a location in Antarctica where meteorite hunting is a booming business, because you're out on these ice fields, and all the rocks you see sitting on top of the ice fields, a large percentage of them are meteorites. So it's a great place to go meteorite hunting. And so this was found in ice sheets of Antarctica. And does anybody know how they're sure it's a Martian meteorite? 95% carbon dioxide. Yeah, it's a dead ringer for the atmosphere of Mars, even down to the isotopic composition. So that's how they can tell it's from Mars. And then there was a big thing in the news a number of years ago now about the presence of these structures inside this meteorite, microscopic structures. Now this structure here, this is one of the larger ones, and I think it's about 100 nanometers long. And the idea was that this is some form of a microfossil of a bacterium. And so this got a lot of press, but then the detractors of this idea came out and said, well, you know, we've been studying bacteria on Earth for a long time now, and this is awfully small to be a bacterium. So we think that the smallest size for a bacterium ought to be about 200 nanometers long. And so there's been a debate going on, that's still going on, where one group of people say that there's such a thing as a nanobacterium, which is smaller than most of the bacteria that we know of today. And then another group of scientists say, well, no, those examples that you have of nanobacteria here on Earth really aren't life forms. And they've come up with an abiotic origin to get these morphologies. So this is actually possible it's possible to get these long morphological structures using abiotic techniques. And so there's really no absolute proof that these are fossils of microscopic organisms from Mars. But there's still a chance. And so even if this isn't an example of it, there's still a chance that some other rock might have a much more obvious and larger